Hello everyone, this is Divya, working as assistant professor in EEE department at St. Peter's Engineering College. Today I want to discuss about physics of wind power. That means what is the historical background of the wind power, that means wind turbine, belongs to the subject wind solar hybrid energy systems. A wind turbine, or alternatively, it may be called as wind energy converter, which is a device that converts wind energy, that means kinetic energy, into electrical energy. So, wind turbines are manufactured in a wide range of vertical and horizontal axes. The smallest turbines are used for applications such as battery charging for auxiliary power for boats or power traffic warning signals, etc. And larger turbines can be used for making contributions to a domestic power supply while selling unused power back to the utility supplier via the electrical grid. So, the large turbines is known as wind farms and are becoming an increasingly important source of the intermittent renewable energy and are used by many countries as part of the strategy to reduce their reliance on fossil fuels. So, one assessment claimed that in the year 2009, wind had the lowest relative greenhouse gas emission, so that least water consumption demands and the most favorable social impacts. So, compared to photovoltaic, hydro, geothermal, and coal and gas, only wind form of from wind energy to electrical energy generation is very best. So this wind energy is created when the atmosphere is heated unevenly by the sun. So some parts of air become warmer than others. So these warmer patches of air rise, other air rushes and into replace them. Thus the wind blows. So it works opposite of fan turbine blade spin from the wind and make energy instead of using energy to make a wind. So the first windmill used to produce electrical energy was created in the year 1888 by Charles F. Brush. So the wind power program in India was started during 1983-84 with efforts of the Ministry of Non-Conventional Energy Sources. And next we will deal with the components of wind turbines. That means these are the main components: blades, rotor, nozzle, tower blade, and these are the inner components. That means main bearing, gearbox, brake, yaw mechanism, flow shaft, manometer. These are the inner components. So coming to the components, wind turbines converts wind energy into electrical energy for distribution. Conventional horizontal axis turbines can divide into three components: the rotor, which is approximately 20% of the wind turbine cost and includes the blades for converting the wind energy to low speed rotational energy. So the generator, which is approximately 34% of the wind turbine cost, include the electrical generator, the control electronics, and most likely a gearbox. Adjustable speed drive and continuously variable transmission component for converting the low speed incoming rotation to high speed rotation suitable for generating electricity should be also in these components only. The surrounding structure, which is approximately 15% of the wind turbine cost, includes the tower. That means this one tower and this is the raw mechanism. A 1.5 megawatt wind turbine of a type frequently seen in our country has a tower 80 meters high, that means 260 feet high. The rotor assembly blades and have weights 22,000 kilograms. The nozzle, which contain the generator, weight 52,000 26,000 kilograms, and the concentrate base for the tower is constructed using 26,000 kilograms. Reinforcing steel contains 190 cubic meters of concrete, and the base is 15 meters in diameter and 2.5 meters thick near the center. So, due to the data transmission problem, structural health monitoring of the wind turbines is usually performed using several accelerometers and strain gauges attached to the nozzle to monitor the gearbox and equipment. So currently, digital image correlation and stereophotogrammetry are used to measure the dynamics of the wind turbine blades. So these methods usually measure displacement and strain to identify the location of defects. So the dynamic characteristics of non-rotating wind turbines have been measured using digital image correlation and photogrammetry. So the three-dimensional point tracking has also been used to measure the rotating dynamics of the wind turbines. So coming to the functions of the components, the foundating gives support to wind turbine. It consists of a solid concrete assembly. And coming to the tower, it connects the rotor and foundation and rises a rotor so that it can operate at required wind. Made up of steel having tube-like structure. And rotor blades, it is a rotating part which converts the wind energy to rotation. It is made up of glass fiber, carbon fiber, reinforced plastic, and massive contains the key components of the wind turbine, including the gearbox, yaw system, and electric generator. And low speed shaft connects the rotor hub to the gearbox. High speed shaft drives the electrical generator by rotating at high speed. And the gearbox converts the rotor motion of lower RPM into the higher RPM. And coming to the coupling is done between the main shaft and transmission. And coming to the generator, it generates electricity from the rotation of the shaft. And coming to the controller, it is a self-operating system used in control system. It may be a sensor, that means mechanical, electrical, decision elements, and relays, microprocessors, and actuators, that means hydraulic or electrical. And coming to the yam mechanism, turns the nozzle with the rotor into the wind using motors. So animator and wind vane measures the speed and the direction of the wind while sending the signals to the controller to start or stop the turbine. So coming to the working by using these components, the wind turbine will work. So here you can see that this is the normal wind turbine which show outside. So here is the operation representation flowchart. So this is the wind. This is aero turbine carrying coupling generator. This generator will send signal and temperature to the controller. This controller control. This is the load and spread torque controlling signal speed, signal and temperature output power. This is gap control. So the main principle, that is very simple principle. Instead of using electricity to make wind like a fan, wind turbines use wind to make electricity. So wind turns the propeller like blades of the turbine around a rotor. That means the wind process turns this blades so that these blades will rotate, which spins a generator, which creates the electricity. So wind is a form of solar energy caused by a combination of three concurrent events. That means the sun unevenly heating the atmosphere, irregularities of the Earth's surface, and the rotation of the Earth. So wind flow patterns and speeds vary greatly across the various countries. So these are modified by bodies of water, vegetation, and differences in terrain. So humans use this wind flow or motion energy for many purposes: sailing, flying a kite, and even generating electricity. So the terms wind energy and wind power both describe the process by which the wind is used to generate mechanical power or electricity. So this mechanical power can be used for specific tasks, that means such as grinding grain or pumping water in the previous days. Or a generator can convert this mechanical energy into electricity. So a wind turbine turns the wind energy into electricity using aerodynamic force from the rotor blades, which work like an airplane wing or helicopter rotor blade. So, when wind flows across the blade, the air pressure on one side of the blade decreases. So, the difference in air pressure across the two sides of the blade creates both lift and drag. That means if wind acts on this blade, this will push us down and this will comes up. So this will create a lift and drag. So the force of the lift is stronger than the drag, and this causes the rotor to spin. So the rotor connects to the generator either directly, if it's a direct drive turbine, or through a shaft and a series of gears. So a gearbox that speed up the rotation and allow for a physically smaller generator. So this translation of aerodynamic force to rotation of a generator creates the electricity, which is further connected to the load as shown here. So this is about the working of a turbine, wind turbines. Thank you.